In this video, we're following up with our present value annuity and future value annuity. Present value annuities correspond to this amortization, to where we're paying off a loan. And we know the loan amount, but we need to determine how much the payment amount is going to be. So if we take our present value annuity formula that we had from the previous video, we can solve for R. Remember that R is the payment amount. We solve for R by dividing both sides by this bracket set. Or when we divide, that flips the fraction, right? So this R over M in the bottom goes in the top. This 1 minus 1 plus R over M to the negative MT is going to go in the bottom, right? Giving us the formula to calculate the payment amount in this amortization. All right, this is any time that we are taking a loan out, right? A home mortgage, a car loan, we can determine the payment amount given the loan balance. All right, so we can jump into some examples. What monthly payment is required to amortize a loan of $30,000 over 10 years if interest at the rate of 6% per year is charged on the unpaid balance? All right, so we are determining the monthly payment. So using this formula, we can identify our variables and then plug in those numbers. So P is the loan amount, that's $30,000 in this case. R being the interest rate of 6%. It does not indicate how the interest rate is compounded, but we can assume that it's going to be the same compound as the frequency of the payment. So we're making monthly payments, so we would assume that the interest is being compounded monthly. So M is 12, and this loan is over a 10-year period, so T is equal to 10. So now we can plug into our formula. We've got P is 30,000 times 0.06 divided by 12. And we're dividing that by 1 minus 1 plus 0.06 divided by 12 raised to the M times T, 12 times 10 is 120. Now in the calculator, we're going to need parentheses around the entire denominator. Okay, we don't need parentheses around the numerator. That's not necessary. So now we can plug all this into the calculator. So we've got 30,000 times 0.06 divided by 12, then divided by, here's our first set of parentheses, 1 minus another set of parentheses, 1 plus 0.06 divided by 12, raised to the negative 120, and then close that original set of parentheses. And this will give us the payment amount. All right, so if we make payments of $333.06, we'll be able to pay off that $30,000 loan over 10 years. All right, let's take a look at another example here. This one has multiple steps to where we have a home that's purchased using a bank loan of $150,000 at a 4% annual interest. The loan is going to be repaid using equal monthly installments over 30 years. So we want to know what the payment size should be if the loan is to be amortized at the end of the term. How much interest will be paid over that 30-year period? What's the equity after 10 years? Equity being how much you would get after you pay off a loan. That's the value of the home. How much money you have built into it. What's the equity after 10 years if the home is now worth $175,000? And then repeat those steps only with a 15-year mortgage with a 3.5% interest rate. Okay, so let's look at the first part of this question first. What's the payment size? All right, so this payment size, we are using this amortization formula. All right, so this is the same thing that we did in the previous example. We identify our variables. P is $150,000. That's the loan amount. R is 4% interest. M, we are making monthly installments, so this is being compounded monthly. M is 12, and this is over the life of the loan of 30 years. So we plug in our numbers into the formula. Okay, and remember that we need parentheses around that whole denominator. This M times T, 12 times 30 is 360. Okay, so let's see what we have. 150,000 times 0.04 divided by 12 divided by parentheses, 1 minus parentheses, 1 plus 0.04 divided by 12. Close the parentheses and raise it to the negative 360. Close parentheses again. And we have a payment amount of $716.12. So we're going to be making payments of that $716.12 per month for 360 months for 30 years. Okay, so now the next question is, once we pay off that original bank loan of $150,000, right? How much of our 360 payments will have been made towards interest? Right, so after we calculate how much our total payments are, once we subtract the loan amount, the balance will be how much interest that we had paid. All right, so we're making $716.12 payments. $360 times. So over the 30-year period, we paid $257,803.20 back to the bank. $150,000 of that was the loan that the bank gave us. So subtracting that loan amount will give us how much we paid in interest, which is $107,000, $107,803.20. Right, and many people are shocked when they see how much interest that they're paying. $107,000 just on a mortgage on a home loan. And that's actually pretty cheap, right? Look at that interest rate, 4%. That's a historically low interest rate. It's usually not as low as 4%. You can get well into 5, 6, 7, 8% interest rate, which would just increase the amount of interest that you would pay over that loan. So that's a pretty cheap interest that you're having to pay that bank back. Okay, but still shocking. When we get to that fourth step, we're going to compare that interest amount with a 15-year mortgage, and that might surprise you also. Okay, but first, let's look at question number 3. How much interest? We said that's the $107,000 number. Question 3, what is the equity after 10 years that the house is now worth $175,000? Now, the good thing about mortgage loans is that it's a good loan, meaning that that real estate appreciates in value in general. So after over time, the value of your home should increase, right? So like what we see here, after 10 years, we bought the house for $150,000, but it's appraised for $175,000, right? So we automatically have $25,000 of equity built in, right? If we were to sell the house, we would make $25,000 plus however much we've paid off on the loan so far over the 10 years. So we need to calculate that amount. To calculate how much we've paid off on that loan, we're going to use the present value annuity formula that we saw in the previous video. Okay, to where we know the capital R, that's the monthly payment. We've already found that that is $716.12. Right, the small r, that's the 4% interest rate, M is 12, and the T is 30. Okay, so we'll plug this into the present value annuity formula. Okay, let's get this put in, and then we'll talk about what this is telling us when we get our answer. Let me hold off on this exponent here. We need to go back and adjust the time, right? Because, all right, let's adjust this time because 10 years have passed. All right, 10 years have passed. So we no longer have 30 years on the loan, right? How much time do we have left, right? This time now, that is how much time we have remaining to pay off the loan, right? So after 10 years on a 30-year loan, we now have 20 years remaining. So T should be 20. And so this M times T, that's 12 times 20, that's 240, right? That's how many payments we have remaining when we're calculating the equity, right? So we have, right, we've made 10-year payments, right? We've made 120 monthly payments. That means we have 240 monthly payments to go. Okay? And this will tell us, once we put this into the calculator, what the balance of our loan is. All right, so $716.12, parentheses, 1 minus another parentheses, 1 plus 0.04 divided by 12. Close that parentheses and raise it to the negative 240. Close the first set of parentheses and divide by, yeah, we need another parentheses here around the denominator. Okay, yeah, we need a parentheses around that denominator there. All right, so that gives us an amount of 118,175.45, right? So this is $118,175.45. This is the balance of the loan. All right, this is how much we still need to pay off. So to find the equity, we can subtract how much the house is worth now minus the loan balance to find the equity. And that is 175,000 minus that 118,000 number. And so our equity is $56,824.55. Right, so that means we could sell the house, and that's how much we would have left over after paying off the balance of the loan. Okay. All right, so now we want to repeat this example using a 15-year mortgage. Using a 15-year mortgage, what difference would that make? If you have a 15-year mortgage, your interest rate is a little bit lower, right? So that's where it's set at 3.5%. All right, so we want to calculate the monthly payment. All right, so the loan is $150,000 times the interest rate of 0.035 divided by 12 divided by 1 minus 1 plus 0.035 over 12 raised to the negative m times t. It's only a 15-year loan. 15 times 12 is 180. So we only have 180 payments to make. All right, but what we would expect is that since we're taking half of the time to pay off the same loan amount, right, of course, the monthly payment is going to be larger. $150,000 times 0.035 divided by 12 divided by 1 minus 1 plus 0.035 divided by 12. We're raising that to the negative 180. Okay, so our monthly payment went from $716.12 to $1,072.32. All right, so we're paying, about an extra $350 a month. Okay. But let's see what that's going to do to the amount of interest that we pay over the life of the loan. All right, how much interest are we going to pay over the life of the loan? So on this, right, so this is how much we're paying per month times 180 months. So we can take this $1,072.32 multiplied by 180. That's how many times we're making that payment. That gives us a number of $193,017.60. Right, that's how much we made in payments. And now, how much did we pay in interest? We subtract the original loan amount minus $150,000. And this is how much we're going to pay in interest, $43,017.60, right? Compare that to the 30-year mortgage, right? We paid over $100,000 with a 30-year mortgage just in interest, compared to the 15-year mortgage, we're only paying $43,000, right? Which is still a lot of money, right? But it's less than half of what we would pay with a 30-year mortgage. Right? So there are many advantages with this 15-year mortgage. You want to make your loan amount, the time you have on your loan as short as possible, because that minimizes the amount of interest that you make, and you have a lower interest rate also. So lots of advantages there. So when you go and you consider buying a house, a few years down the road, remember to try to stretch your budget a little bit and take out a 15-year mortgage. You'll pay a little bit more per month, but you get paid off twice as fast, and you save a lot of money there.